finish up the Git flow lesson. Let me just get it set up. All right, so just to remind you about the goals for this lesson and where we sort of left off yesterday. The goals of this lesson are to be able to describe the basic Git workflow, which we shortened to Git flow, to create multiple branches within a Git repository, and make a pull request from one branch into another. So yesterday we talked through like conceptually what Git flow means and how you do it in practice, and also like the advantages and disadvantages of it. So now we're going to do a little demo of Git flow. So I'm going to do a couple things. I'm going to raise an issue in a repository. This isn't necessarily like specifically related to Git flow, but it's a good thing to know how to do. We're then going to create and manipulate multiple branches within a Git repository, main develop feature. Then I'm going to demonstrate how to use these branches in a standard Git workflow, and then submit a pull request to merge two branches. All right, so let me open up GitHub. Can you see my whole desktop on? Okay, great. Okay, so I'll just go to my landing page on GitHub. All right, and this will probably have a little bit of overlap from what you've already seen, hopefully several times. The justification of that is that this stuff really, you learn it a lot better with repetition. And there's also a lot of different ways to do the same thing, so you'll see like a slightly different version of this workflow. All right, so I'm gonna create a new repository. I'll just click this new thing here. So I always really like the ones that GitHub suggests, so I usually use those as like demo repositories. Is the text big enough, by the way? Not as much in the back. How's that? Okay, great. All right, so let's make a new repository called solid octo fish stick. Fish stick. I'm pretty sure Octo was also in the one that I made the video about. I don't know what they're on with Octo. I'm really excited about that. All right, I'll make it a public repository. I usually add a README file, and then I'll also usually add a gitignore template. So this is like a list of files to not track through Git. So these are things like any system level things like compilation files and stuff like that that would need to be remade on each individual person's machine. And you can add stuff to gitignore yourself, but this template has a lot of nice stuff that you don't necessarily want to include in your repository. You can choose a license here. I'm going to talk a little bit more about licenses on the releasing code day, so I'm going to just skip that for now. I don't know. I guess maybe someone might want to use solid octo fish stick in the future, but I'm going to assume that not really. Okay, so the first thing we're going to do is raise an issue. So I'm going to do this. The purpose of raising issues is, I guess there are two situations in which you might want to raise an issue on a repository. One is as the main developer or a developer of the repository, you might want to create a list of things that are ongoing. And this is a public facing list. So if someone navigates to your repository and wants to know what are the open bugs, what are the things that people are working on, this is a good place to keep track of that stuff. I use the issues list as sort of a to-do list for myself. You could also raise an issue as a user of the repository. Maybe you have a feature request, maybe you ran into a bug that you want people to take a look at. So the process looks pretty much the same in both cases. So let's take a look at how this works. So you add a title for the repository, or for the issue. I'll say solid octo fish stick doesn't do anything. I might add a description of what I want to do. Some repositories will have templates for the type of what they want issues to look like in a standard form. Solid octo fish stick is useless. Please add some code. All right. Another couple useful features are you can add assignees. So you can assign this at the point when you're submitting the issue, or like as the developer when you're going through later, you can like assign these issues this way. I'll assign myself since I'm the only person that's working on this repository. There's also this nice set of labels that you can go through to organize the issues. So the ones that I use a lot of these all the time, actually. So there's a bug, a documentation, enhancement, and good first issue. Good first issue and help wanted are nice ways to sort of signal to people that might be wanting to work on your repository, like this is a good one to start with. And yeah, if you have particular projects, I guess we're not really talking about the projects, features. Milestones, we ended up making milestones for Orbitize when we were working towards particular versions. So this is a really nice way to say, like, you know, here's a set of issues we want to work towards for V1, here's a set of issues we won't work towards till V2, or like longer term. All right, so we're going to submit this issue. So you now see in the list, it's got a number that's assigned, and then if we click on the issues, it'll show a list of all the open issues. All right, so let's set up solid Octo fish stick for Git flow. So if we go back to the main landing page of the code, you can see in this button here, this shows all of the branches. So right now, when we first created this new repository, we only have one branch, we have main. So the next thing we'll need to do is to set up a develop branch in order to be fully compliant with Git flow. So we can do this just by typing in the name of this branch here. So I'll call it develop. And then you can see this option, create branch develop from main. So from main means that it's going to be basically a copy of main. So let's do that. So now you can see we've got two branches, main and develop. So now at this point, our repository is like set up for Git flow. So we need to just start creating feature branches and actually developing on them and then pulling them into develop in main. So good practice for naming, good practices for branch management in general are that your branches should be as specific as possible. It's good to have like a lot of small branches rather than having a couple of large branches. And the reason for that is that if you have a branch that like you're working on for months, the like base of the repository might have a lot of development, and your code on your branch might quickly sort of get out of sync with that main branch. So small branches with little bits of code that are pulled and started over more often is better than big things of code. So let's build a new, another thing I was going to say, the reason I brought that up is that it's also good to have pretty specific names of your branches. I tend to prefer longer, more descriptive names over shorter, less descriptive names. So let's say you can also have your branch names be like addressing a particular issue. So let's say create first code. So that'll be the name of our branch. And you can see it's creating branch create first code from develop. If we were currently on main and not develop, it would create it based off of main. Doesn't really matter at this point. They're both exactly up to date. All right, so let's create this new branch. And then we're going to add our functionality. So our issue was that solid Octo fish stick doesn't do anything. So let's have it do something. I'm going to do this all within GitHub, but I don't usually code that much in GitHub. I don't code usually in GitHub. The only things I'll actually like modify in a repository from GitHub are like documentation changes. Every once in a while, if it's like a very, very small thing, I might actually like code within the GitHub UI. So let's go to the README. Yeah, okay. I'm gonna create a new file. So let's call it do something.py. All right, and we'll have it do some functionality. What should we have it print out?
Fish sticks are delicious.
Thank you, Matt. Fish sticks are delicious. Wait, it's 8, so 8 exclamation points. 1, 2, 3, 4, 5, 6, 7, 8. Great. All right, and then we're gonna commit our changes. We'll add a commit message. So added do something .py to add functionality to package. And then in the extended description, it's also generally good if you're addressing a particular issue to cross-reference that issue in as many places as possible. So since we're doing this specifically in response to issue number 1, I might add in the extended description of this commit, like addresses issue number 1. And you can see GitHub does this nice thing where it'll like actually tag the issue so you can like navigate back and forth. All right. So I'm going to commit this directly to the create first code branch. You can see from this UI, you could also even create an entirely new branch that's built off of this current branch that we're on. Okay. So now we have 3 branches. We're fully in compliance with Git flow. We've got main, we've got develop, which is branched off of main, and then we've got create first code, which is branched off of develop. So the next step is to pull our feature branch into develop. So we'll create a pull request. So you can do this by going to the pull request tab up here. You can see that if you have recent changes to a particular branch, it'll actually pop up and suggest that you create a pull request. You can also create a pull request from any branch, just pressing the new pull request button. So let's do that. And then there's 2 things that you have to choose here. You have to choose the branch you're pulling from and the branch you're pushing to. So in this case, we want to push to develop, and we want to pull from create first code. So all our changes are going to be pushed into develop after this pull request is complete. And you can see it pulls up this nice user interface with like the changes that we made. So you can see it added this file, and then it added this line in this file. All right, so let's create our pull request. You can create like more description of the pull request here. So generally, if there's like several commits, you might want to like give an overview of like what each commit did, or like list all of the issues that this addresses. It also automatically fills in, I think it's the last commit, so the most recent commit. I think that's a reasonable description, so I'll just leave it. I'm going to create my pull request. So if I were like an outside contributor to this repository, I would probably leave it at this and just let the main developers review my pull request, suggest changes. But since this is my own repository, I'll actually show you the process of like reviewing the pull request itself. Sorry, just pulling the pull request in. You can also like perform an actual review and like suggest specific changes. So here I'm just gonna merge pull request. Actually, let's look at some of these things here. You can, if you look at, there's a list of all of the commits you made on this tab here. So you can see my commit message, added do something to functionality to package. If you have automated tests set up, this is the tab where they'll run. We'll talk more about automated tests on Thursday. And then you can see also which files were changed. So commits is like a list of the commits you made in order. Files change will show you like the net changes that were made overall. Another thing is that you can like have a long chain of like conversations with reviewers or with people developing the package. All right, so say we did that whole process. Let's merge the pull request. I'll confirm the merge. And then at this point, if we go back to the code on develop, you can see that we have do something in here. So this branch has been fully merged. And then best practices are also to, another best practice that I want to briefly mention is that it's good to delete the branch once it's been pulled in, because basically you want your open branches to be a list of like active branches and not like a graveyard of every branch. The nice thing about Git is that they're not gone, they're still in the history. So if you really want to go back to a previous package, you can do that, or a previous deleted branch, you can do that. But it's also within the Git history of the current of the current branch on develop at this point. So you're not like losing it if you're deleting it, you're just sort of cleaning up your list of branches that are active. So, oops. In order to delete branches from GitHub, you go to this, open branches, and then you can see it's got this nice organization of all the branches, and then create first code, you can just click the delete here. And you can also see there's this thing that says what the description of the pull request that was already completed. And this little like purple thing indicates that it was merged. So this is like, yeah. All right, so let's delete this. Then if we look at all of our branches, we've just got main and develop now. So that's Git flow. We would then, continue contributing to develop until we had enough to merge into main. The last thing is that now that we've addressed our issue, we want to close the issue. So you can see that this is also like GitHub keeps track of the fact that this issue was specifically referenced in a pull request recently. So I generally also, even though I'll generally also like say the pull request that it was addressed in the conversation on the issue here. So I'll say like addressed in PR number 2. And yeah, so you can either just comment and keep it open or close with the comment. So let's close this issue. All right, so now we don't have any more open issues. So congrats everyone. Solid Octo fish stick does something. All right, so that was the demo. You still see my screen online?
Yeah.
Okay, great. So just an overall summary of the process to add a feature. This is from the perspective of a repository that already has Git flow set up. So you first pull the latest code from developer main, depending on what the developers are using as like the active branch. Create a feature branch from that branch. Make your changes, stage and commit, then push to your feature branch. Then submit a pull request on GitHub and merge your feature. Once your pull request has been approved, merge that feature into developer main. And then if you are following Git flow and you're only merging into develop, you'd repeat that process several times until you're ready to like release a new version or something. And then you make a pull request from develop into main. All right, so now let's spend 15 minutes. There are 2 things that I want you to do. The first is I want everyone to make sure you can git pull the most recent version of the Code Astro repo. So this hopefully will be very easy. If you're doing this from VS Code, you can just press the bottom left button, the like little arrows. And then the second is to set up a Git flow compliant repository within your project groups. So basically just doing the process that I did to hopefully like give you a sense for how this works. So you want to create, main, develop, and at least 2 feature branches. Ideally, if you're doing this with someone else, you would each create a feature branch so you can see the process of working together on this. Raise an issue, clone the repository to your machine, which I didn't show you, making changes on each of the feature branch, and then opening pull requests to merge them into main, and then perform the merges. All right, so we'll take 15 minutes. Go.
All right, let's get back started, everyone. So we've spent the last couple of days talking quite extensively about Git. And one of the things we talked about was we gave you a bunch of things you can type and do, and you follow a procedure. And that procedure seems like maybe there's a whole black magic scene happening behind the scenes of things going on. So for the next hour, we're going to try to understand Git just a little bit. So we can take a second to appreciate the meme. These are all Code Astro originals, by the way. Okay, so we're gonna try to move ourselves from people who just we just copy a series of commands, and hopefully our repository is in the right state to try to figure out, what command should I be typing at what point.
Oh, Jason, you're showing just dirty on this one.
Oh, thanks. New share. Great. All right, so we're gonna try to do mechanics of Git. So just a little disclaimer. I made up this model, this thing. So this is and it's it does simplifying the actual underlying Git implementation, but the actual underlying Git implementation is so weirdly complicated in weird ways that we're not gonna go to exactly how it's implemented. We're gonna go one abstraction level above to think about what's happening under the hood, but not so to figure out exactly what file is happening, like what operation exactly is Git doing and where is that information being stored. You should never need to know that, and it's actually very dangerous to actually try to reverse engineer that. But we're trying to have a mental model that's useful for us to think about what's happening under the hood, so we can kind of figure out what's the next command we need to type. Um, so um, so yes, just to bear in mind, this isn't actually exactly the exact implementation, but the exact implementation, when I read about them, like we are definitely not teaching that. Okay, so the fundamental kind of cornerstone of Git is this Git commit object that we've been making. We've been making all these Git commits, and then we've been pushing them, and we've been adding things to them. So you can think of this Git commit as an object. And this object has a bunch of different attributes. So it has the attribute ID, which is the Git ID. It's like that string of jarbled letters and numbers that you keep seeing for you every time you make a new Git commit. It also has a parent ID. It's which Git commit did this commit spawn from? So so it has a ID, it has a parent ID. It also has a list of changes, in this commit, what files were changed. Maybe we created a new file input.py, we added text on line 0, we modified a file plot.py, we added text on line 12, we deleted text on line 36, it contains a whole list of changes of what happened between its parent commit and this commit in terms of what changed in the repository. It has a message. This is your -m that you always do when you do git commit -m that gets stored in the git commit as an attribute to the commit. It also has metadata, such as like the author of the commit, the email of the author. The email of the author is actually what's used by things like GitHub to track, who contributed what, how to link your Git commit to an account on GitHub. And then the time of the commit as well. So it has all of these things, and this is kind of the atomic unit of our model. We're not going to try to subdivide this Git commit into other things. The actual underlying model does in confusing ways that we're not going to go into. This is kind of the indivisible thing. We're going to make a single Git commit. And a Git repo will basically consist of a chain of Git commits. You make a bunch of different commits to the repo, and then that ends up with the current state of your repository. All right, so we're gonna do literally Git by hand. So we're gonna let's pretend we're writing a package that makes color images, and we're gonna plot them. That's the whole purpose. Like we're gonna have all these fits images at different wavelengths, and we want to make them turn these false color images into images we can see, but with human eyes, and then plot those color images. That's the story. We have to have a story for this whole thing. All right, so let's say I want to get started in this project. So I type git init, and now initialize this folder to be a git tracked folder. And what that actually does is that it creates a folder called .git, and everything that Git is doing under the hood to kind of maintain its source control is happening in that folder. You should probably never need to go into that folder, but all the magic, the black box, is inside that folder. Okay, so let's say, I'm going to actually do some code. So I go type, create and add. So I basically make this file called color.py, and I put a bunch of code in there. And then I do git add color.py, and then I do git commit -m initial commit. And my terminal, just like how you saw yesterday in Matt's demo, will spell something like main 309f initial commit one file is changed, create color.py. And that's what your terminal spits out. And what happens in our kind of our Git model here is that now we have a single Git commit 309F. It has a bunch of attributes. Its ID is 309F. Because it's the first commit, it has no parent. It has a list of changes. We created this file color.py. We added text on line 0. And then the message for it is initial commit. And then we can also have metadata and so on. So we've created one commit now in our mental model of Git. So then let's say, we found, while we were trying to use that code, we found that it wasn't actually displaying any of the images we defined to be red. So like it was only displaying green and blue. So we're like, oh, we got to fix this red color bug. So we go type, fix that bug. And then we go add color.py. And then we do, again, git commit -m, fix red color bug. And then our terminal, again, like you saw yesterday, spits out something like main 8A6C, fix red color bug. One file is changed. And what happens is that now our git commit tree has a new commit, a second commit, 8A6C. Its ID is 8A6C. Its parent is 309F. It has a list of changes, modified color.py. We added text on line 12. We deleted text on line 36. And the message it had was fixed red color bug because that's what we put in. And notice how in this time, it's the only time I'm going to do this, but we're drawing these like one directional arrows that's pointing 8A6C at 309F because 8A6C knows that 309F is its parent commit. It is created from the foundation set by 309F. But 309F, if you recall, knows nothing about 8A6C, right? This is everything in 309F. None of it knows about what commits come after it. It only knows about itself and its parents. And it's only the next commit that knows about what's in, what spawned from previously. So 309F knows nothing about the existence of 8A6C, but 8A6C knows about 309F. Okay, we're going to drop these arrows moving forward just because I got lazy, I think. I think I got way too busy in the PowerPoint. Okay, so let's say we keep on programming. So we want to now make a plotting module so we can display the images we created, because that's the whole purpose of this, right? We gotta show the images. So we go type, and then we go git add plot.py, git commit -m, added plotting. And then our terminal will spit out main 91E1, added plotting, one file is changed, create plot.py. And what happens now is that we have a third commit, 91E1. Its parent is 8A6C. It has a list of changes, create.plot.py, and it has a message added plotting. And once again, 91E1 knows about 8A6C. 8A6C does not know about 91E1, and 309F doesn't know about either of them, right? So each commit knows about its parent, and that's just kind of just remember that when you go to a previous commit, it knows nothing about what's happening after it. It only knows about the past, just like us. Okay, so this is our timeline. So this is kind of a one directional timeline. We just move our way. We start from 91E1 and then we go back to 8A6C, go to 309F. We have all the changes, and now so we know how we can build all the code in our repository. It's the whole list of changes that records the entire history of the repository to know how to get to our present state. Okay, so now let's talk about alternate timelines, which is Git branches. So that's what we're talking about for Git flow, making all these different branches. So what are branches? So branches we showed allowed people to work on separate features in parallel. The base branch is usually called main. You might also see master. That was like an old one, but we don't really use that anymore. And then Git branches they're nothing more than just pointers to the most recent commit in a timeline. So what pointers is a term in software development. Pointers themselves don't contain any information. They just point to where the data is. So lots of things in Python and things like that are pointers. You don't really have to think about them. But in this case, it's useful to understand that Git branches are not some big monstrous thing. They're just pointers in our Git commit tree. So commits, again, if you remember the attributes of a commit, also don't know anything about branches. Commits don't think about what branch they're on. Branches basically point to the last commit in their timeline. So now we have the main branch. So main branch is pointing to 91E1. So we go to 91E1, we go to 8A6C, go to 309F, we can construct the main branch. There's also something special called the head pointer. The head pointer is just pointing to where what state of the repository is your current local repository in right now. So it can point to any arbitrary commit. You generally don't want that. Generally, it's pointing to one of your branches. So the main pointer is pointing to the head pointer is pointing to the main branch, which is pointing to 91E1. And that's generally how the head pointer works. But you can literally point the head pointer at 8A6C. And then your Git terminal will tell you you're in a detached head state, which just means that your head isn't pointing to somewhere not on any branches, it's pointing to some arbitrary part of your Git commit tree. But generally, your head pointer is pointing to one of your branches, so we're here pointing to main. So the main pointer, which is also where the head is pointing at 91E1, and this is our single timeline in the Git commit tree. So what happens when we create a new branch? So let's say I want to make the plotting interactive. So I want to be able to adjust the coloring by eye, balancing the different amounts of red and green and blue. So let's make a new branch to work on that. So if we type git space branch space plot upgrade, and then that will create a new branch. But if we type git status, right now we're still on the main branch because it says on branch main. So what we've done right now is that we've created two branches. Our Git commit tree has looked the same. We still only have 3 commits. Nothing has happened to our commit tree. What happens is that on our list of branches, we now have a second branch. It is called the plot upgrade branch. It is also pointing to 91E1, which is the same as where main is pointing. So you can see both plot upgrade and main are pointing to 91E1. And the head tells us we're tracking main. So if main ever moves, we're moving. But if plot upgrade moves, we're not moving right now. Okay, so let's switch to our new branch. So we can type git space checkout space plot upgrade. And that's going to switch our head pointer to point at plot upgrade. So now we do git status. It says we're on branch plot upgrade. And you can see the only thing that changed between the previous slide and this slide is that we've switched from our head pointer from the main branch to the plot upgrade branch. So now we're going to follow the plot upgrade branch and wherever it goes. All right, so let's say, let's actually, do our coding. So we, do our classic type, and then we, make a bunch of changes to the code, and then we add them. So we do git add color.py, git add plot.py. And then we do git commit -m interactive. So then our Git terminal outputs to us plot upgrade 353b interactive, 2 files changed. So what we've done here is that we've now made a 4th commit. Where's my mouse? 353b. Its parent is 91E1. Again, remember 91E1 knows nothing about 353b, but 353b knows its parent is 91E1. The main pointer is still pointing at 91E1, so the main branch is still 3 commits starting at 91E1, but the plot upgrade branch, you can see, has now changed its pointer to 353b. The head is also pointing to plot upgrade, which is pointing to 353b. So the plot upgrade branch now has an extra commit 353b compared to the main branch. Right. So what if while we were doing that, we realized we had a bug in our original plotting code? It wasn't like there was nans in our images, not in numbers, and we wanted to fix that. So what we would do is that we would do git checkout main, and then that was, switch our head pointer to the main branch, which was 91E1. Then we do our classic type. We add, make a bunch of changes to color.py. We add them, so git add color.py. Git commit -m fix nans, and then our terminal will spit out main A329 fix nans 1 file is changed. And what has happened is that now we have a 5th commit A329, and that's now where the main branch, which is also conveniently where the head branch is pointing at too. So the main branch now has 4 commits: A329, 91E1, 8A6C, 309F, and the plot upgrade branch still has its 4 commits. Again, note that 91E1 knows nothing about either of its child commits, so it doesn't know that it in fact has 2 different diverging branches right now. But that's the current state of our repository. This is one timeline. This is the second timeline, and our branches are pointing to the ends, the present day locations of each timeline. Okay. So let's say we want to actually finally merge those changes. So we tested that everything in the interactive branch is actually working. So let's merge the changes that we have. So we wanted to make sure, so you want to merge from one branch into a different branch into a desired branch. You first check out that desired branch to merge into. So you do get space checkout space main. This is the same. This series of steps is kind of similar to basically doing a pull request on GitHub. This is what a pull request on GitHub does. So right now we're just doing it on the command line. So we do get checkout main. We do get status. It tells we're on the main branch. That means the head pointer is pointing at A329. And then we do get merge plot upgrade. And then if there are no conflicts, Git will automatically make a merge commit. So we have a new merge commit that's 8443. It's a little bit special because it has two parents. It is merging from 353B and merging into A329. So we know that we're taking both states of the repository, merging them together and creating 8443. So now, and you can see, we have changes. We modify color.py because that's what we modified in the plot upgrade branch. Then we have the message merge branch plot upgrade. So this is what a pull request on GitHub does. This is what you can also do on your command line. We have 8443. So now you can see the branches. Plot upgrade hasn't changed any bit still. It's still pointing at 353B, still has 4 commits in its timeline, whereas the main branch is now pointing to 8443 and has 5 commits. All right, so let's think about an alternate history. This is the nice history where this is a nice kind of situation where there's no conflicts. Git will automatically make the merge commit. What happens if we try to do git checkout main and then do git merge plot upgrade, but then we hit the dreaded merge conflicts in color.py? What happens then? So basically that means that our edits in color.py conflict from the 2 different branches because both branches made edits to the same file, probably at the same location. So we had to manually resolve those conflicts ourselves. Git has no idea how to program. So here's an example. Right, so maybe on the main branch to fix that nan color bugs, we had to add this keyword mask nans into this function called toPNG or something like that. And maybe on the plot upgrade branch to make things interactive, we also want to have an optional keyword. So we added this optional keyword interactive equals to false. And they both happen at the same line of color.py. Git is not a programming thing. It doesn't know how to merge these things. So when you do a git merge plot upgrade, what happens, as you might have encountered in the last couple of days, is you'll get all these these little brackets is telling you that basically the current head pointer, so where our current state of our branch is, this is what the code looks like, toPNG, and has that mask nans keyword. Whereas the branch you're trying to merge into our current state, the plot upgrade branch has this other definition of toPNG, and they are conflicting with each other. So Git's like, I don't know how to do this. You guys figure it out. So you have to resolve this conflict manually yourself. One way we can do it is just manually do some code editing and decide we want to keep both keywords and both functionalities. So let's change the signature of this function to include both keywords. But that's something we have to decide. Git is not going to decide that for you. Git has no idea how to program. Where's my to keep this in? Okay. So if we fix those conflicts manually ourselves, then we do a git add color.py to add those conflicts that we manually fix. We add because we did additional new changes. So we're still in that same merge commit. We haven't made that merge commit yet. We're just adding additional changes to that merge commit to fix all conflicts within the commit. So we're adding our additional changes in color.py, and then we do a git commit -m and merge branch plot upgrade. So now we'll create finally our commit 8443 merge plot upgrade. 1 file is changed. And you can see that this commit tree looks exactly the same as the previous one where there were no conflicts. So this and Git itself doesn't care that much about whether there were conflicts or not during a merge. All of the conflicts or lack thereof are also stored in this changes attribute. It has a list of changes, so it knows that color.py got modified, and in this case, there were manual changes that were also included to fix those conflicts. In the previous case, it was just automatic merging. So that's the only thing that happened. Everything else still the same. The ID is still 8443. It's still merging from 353B, merging to 8329. Has the same message. The current state of our repository is still the same. Main still has 5 commits. Font upgrade still has 4. It's still the same kind of version history. Okay, so that's kind of a basic mental model of Git that, at least for me, helps me figure out, what is the next command I need to run. And we've taught you basically all the commands I like 99.5% of the times I use when running Git. Like I don't use a single other command other than the ones we showed in the last 2 days of the workshop, basically, except for git stash. I guess we technically showed you that, but I'm not explaining how git stash works here, but we can explain that later if people are interested. Okay. But basically, with that, we were able to kind of figure out, when should I do a merge? When should I do a checkout? When should I do a git branch? When should I do a commit? What's currently wrong with my repository so that I can get myself to the state I need to be to figure out to my desired state of the repository, basically. So gonna give you some practice doing this now. So we have 2 activities. One is, let's say the current state of our branch looks like this on our computer, and we want to run a git pull or git pull origin main to pull the updates from remote, and then draw out what happens. Yeah, you're gonna draw out. This is so you can use like PowerPoint, use pen and paper, use whatever drawing software you want to draw circles and lines. To figure out, to draw out what will be the state of our repository in each of the 2 following scenarios. Either the remote branch is ahead by extra commit, or the remote branch also has 3 commits, but the 3rd commit is 832E instead of 91E1. And then if you can finish this, we also have a second activity where, oops, I totally committed something wrong at 91E1. I want to revert those changes. And then there's 2 ways I've listed here to how to revert changes. You can do a git revert 91E1 or a git reset -- hard 886C. So learn about these 2 commands online and try to figure out what happens to the commit tree when you draw each of those 2 situations. And when you're done, I'm gonna post 2 questions on Piazza. So to respond to those questions with either your answers to activity 1 or activity 2. Let's aim for, what did I say, 25 minutes. So we'll come back at 30 minutes after the hour and recap. Okay. And I'm gonna make this. All right. So you guys got everything except for the last one, which is the hardest one. The hardest one is the trickiest one. So the other 3 look exactly like what you guys showed. So the remote branch is ahead by extra commit. We add extra commit. The remote branch also has 3 commits, but the 3rd commit is now 1E1. We have our merge commit to merge those 2 diverging main branches. Git revert 91E1 indeed creates a new commit that just undoes that previous commits. And then git reset -- hard 886C. It doesn't, we don't, I guess one principle we haven't I don't really mention or emphasize that you don't modify git commits. Like once you make a commit, it's there. That's the permanent record. We're not changing commits once we modify them. What we've done here with the git reset -- hard is that we've changed the pointer of our branch to point at 886C instead. That's all we do. So 91E1 still exists. Its parent commit is still 886C. It's just no one cares about it anymore. It's just sad and just like lone. It's just like floating out there. It knows that this is a timeline that could exist, but no one cares about this timeline anymore. The main branch is now pointed at 886C and says this is the latest state of my branch. I know nothing about anything after 886C. 886C doesn't know about know about 91E1. The main branch now doesn't know about 91E1. No one knows about 91E1, but 91E1 still lives there, saying that this is an alternative universe that could be true. Okay, so that's generally we recommend you to do this git revert because it keeps a record of your revert. Whereas here you'll see that if we did this git reset -- hard, then basically no one knows that even about the existence of this. Like we don't know that we made this mistake and then we had to fix it. We just completely are erasing it from history altogether. And generally, you don't want to do that. You want to track for it, and you want to revert things in case you realize that the thing you reverted actually you don't want to revert, and then you want to do a revert of your revert. So that's, and that has happened. So like you generally want to use git revert on the left and don't want to get reset. Anytime you're doing anything with dash dash hard, you have to question, is this really what I want to do? And in this case, you probably don't want to do it, but you probably will see this on Stack Overflow at some point. So this is just to show you, this is, you can use this kind of mental model to kind of reason through all these cases. But so you've done this, we've given you a bunch of cases which are not described at all in what I taught you in the beforehand, and you figured out with your idea with this model and with your kind of background on Git, what should happen to our state of the tree in each of those cases. So good job there. So that let me just finish with the last couple conceptual points. So let me switch. Oh, great, thank you. What is the Zoom question? Links with git revert, would 3BC7 be the same as 8A6C? Okay. What did with git revert, the state of your repository at 3BC7 will be the same as the state of your repository at 8A6C. The objects themselves aren't quite the same because what's changed, and you remember the field of like what has changed, right? And what has changed, 8A6C probably has a bunch of edits on top of 309F. 3BC7 basically has a bunch of edits that undo the edits of 91E1. So the actual changes to your repository are different, but it puts your repository into the same state. So yes. Yeah, you mean the information there. Yeah, basically the information in your repository will look the same in those two cases. Basically, it's just you have an extra commit to record your previous mistakes. Okay, just the last couple conceptual points. So, all right, you should never now you might think, oh, now I understand how Git works. I can go on like into my .git folder and start doing things. You should never do that. It will destroy the point of source control. It can break your repository, and you'll find out that that underlying .git folder is actually way more complicated than what I just described. Git, this is like pretty like practically we'll probably not run into these things, but Git is actually technically meant to be distributed, which means it wasn't designed with GitHub in mind. Like Git and GitHub are separate things, and GitHub did not design Git. Someone designed Git with this idea that it can be distributed and people can basically, there's no one person that's your central repository. Like anyone could have a version of some code with a Git timeline and basically pass that around. So you can actually technically copy your Git folder between machines, and that's a way. And if you don't want to use GitHub, and basically people can keep track of various changes that way. Effectively, no one does that, but technically it was designed to do something like that. Nowadays, things like GitHub have made it with a central repository. It does make things a lot easier to have a central place where things live. So if you ever see Git is meant to be distributed, know that that is true in the academic sense. But in practice, we use services like GitHub to centralize our code to make it easier to collaborate and share code. So things like Git and things like GitHub are actually built on top of Git. So it's just like Git workflows are, pull requests, issues, all these things are things built on top of Git. They're not things inherent to Git. The things inherent to Git are like Git add, Git commit, Git status, things like that. So just remember that there's actually two layers you're kind of working on when you're doing source control, and trying to sometimes remembering what belongs in what layer can kind of help you, like what's underlying Git stuff that I have issues with, and what is more like GitHub stuff that's built on top of Git that I'm running into issues with. So those are the last conceptual points. let's take a 10-minute break now. So we'll come back at 55 minutes after the hour, and then we'll talk about debugging. All right, let's come back together. All right, it's kind of want to. So, we'll wrap up today. We'll talk about debugging, our favorite topic. So let's take a second to appreciate the meme. This one was made last year, so it's a little bit less old. All right, so debugging is painful. There's no like one golden rule that kind of makes you debug. There's no one process that kind of will be like, this is the solution to all your bugs. There's no one way to be like, here's how to avoid all bugs ever. So we're gonna teach you this one particular tool that hopefully will help you debug. And then I'll end with some best practices to kind of avoid, to kind of like improve debugging and at the end, but there's no golden ticket for debugging. Okay, so in particular, I promised to show you how VS Code can help you with debugging. So we're going to debug some code in VS Code. It's very contrived. So bear with me. It's hard to like make your own code that's inherently buggy in ways that are ways that are very illustrative. You just have to write bugs and not and there's no very few times there's a bug like, oh, that is a very intellectually stimulating bug. It's just like, yeah, we just swapped two variable names. It was just dumb, but it took me like 500 lines of code to find where we swapped them. That's usually how it goes. So we're trying to figure out how to make that faster. Okay, so we have this code that's supposed to generate some pixel art, but it currently crashes. So we're going to try to use the VS Code debugger to fix this. Oh, let me see. Good. Okay. All right. So in day two, I've opened up in day two, there's this debug matrix file. You don't need to go along with me right now. Just watch the screen for now, but know that this exists. So warning, this code is broken. Don't treat it as a model for your own work. I wrote it bad on purpose. The code is supposed to generate random pixel art. The values are integers drawn from random uniform distributions. Okay, blah, 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 blah. Okay, the topics we're going to cover. So first, there's this tool in Python called PDB. It's the Python debugger. The Python debugger is the thing that lets you kind of go into your code and stop at whatever point in your code. And you can access this from the command line, but I really don't like accessing from the command line. Then you have to like, it's not a very good experience. So we're going to use PDB with VS Code. So we're going to show you how to set up the debugging configuration in VS Code and enable post-mortem debugging. So first, let me just delete my debugging configuration in VS Code. Save that. Let's just delete this whole thing. Get rid of this. Delete. Where's the delete button? Remove, delete permanently. Get rid of this. Okay. So on the left-hand side, we can go into this thing called run and debug. And when you see it for the first time, you'll get this whole like run and debug. Don't avoid your instincts and don't press that big button at first. We're gonna first create a. You can do that. It's fine. It's just then you have to do this. You have to click multiple buttons every time you do it. We're gonna simplify it for you. You're gonna click this to customize, run and debug. Click create a launch.json file, and here is gonna ask you what kind of debugging would you like to do? There's a bunch of options, but I think you probably want the Python debugger. And you're like, yes, I do want the Python debugger. So you're gonna click that, and it's like, here's a bunch of ways you can debug in Python. And you're like, oh God. And you'll never need to know any of them probably, except for the first one, which is Python file. And I have literally never used any of them except for Python file. So we're gonna click Python file. And what this does is that in your repository, in your .vs code folder that will now exist, they've created this launch.json file, and it basically specifies, how should we debug in Python. in day 2, we also have a demo launch.json file for you to reference to make sure to see if this looks like it. And you can open that up. And there's only one thing that's different in this one compared to the default one that gets auto-generated. And that is, there's this extra line of code that says CWD file dir name. And this basically sets your debugging environment so that you're always debugging in the current working directory of the file that you're debugging. And this usually makes my life easier because you can, instead of assuming you're living somewhere maybe arbitrarily in your file system, wherever you open up VS Code, you're always debugging in the folder that's the file that you're debugging also lives in. So it kind of keeps me sane. So I always add this. So we can just go into here, into this launch.json, comma, enter, and paste that in and save it. So now we have a debug configuration. So let's go back to our debug matrix code. We have it selected. Notice we have to have it selected. And then we go back to our run and debug. And now there's no big button anymore. There's no tempting big button, except now there's only this very small green button. This is what you actually want. The small green button lets you run. So it's a little tricky. There's another play button over here. This does not run things in debug mode. So that one just runs things. This one here runs things in debug mode. So you want this tiny green button. This is where I said VS IDEs are sometimes tricky. There's a lot of buttons in a lot of places, and you got to get the right one to do the right thing. And sometimes you're like, why do I have to do this? Hopefully, it will save you time in the future. Is what I'm trying to tell you. Okay, so we're gonna run this in debug mode, and hopefully in the terminal you'll see that it will start running in debug mode, and it will crash. My computer is slow right now because it has a lot of files open and it's trying to run Zoom at the same time. Okay. So it has crashed, and we've entered what's called post-mortem debugging. Post-mortem debugging says this is the line that you crashed at, and here's the error that you get. So it's pretty nice, right? So instead of just like your terminal spitting out being like, the thing crashed and here's a bunch of text, it literally tells you what line that you've crashed at and here's the error message. And that's not all. The state of all your variables is exactly at the time it crashed. So you can actually hover over each of these variables and it will tell you what the value of each of these variables are. So you can hover over them and you can inspect all of them. You can even down here, the screen resolution is not very good, sorry. There's a debug console. Debug console, you can do whatever you want right here. It basically lets you run Python commands at the time in the state that your program has crashed in. So you can do things like print pixel RGB. You can do things like print I plus 1. You can set variables I equals 1, print I. And you can do whatever you want here, and it will run just in the same state that your program has crashed in. So you can like play around with things, try to get things to not crash. So like one thing we can do here, let's set I back to equal to 0. I didn't intend to do that. We could do something like, let's look at what is new image j comma I. So we print that out. I got that's 0.0. And then you can also look here and look at what's pixel RGB. You're like, that's many numbers. This is one number, this is many numbers. Seems like we're trying to set one number with many numbers. So like what's going on? It's obviously something weird is going on. So you're like, okay, maybe I don't fully understand things. I want to like run the code a little bit and see what happens. So another way to debug is through what's called breakpoints. So let's say our code crashed at line 45. Let's see what happens before we enter this for loop. So we can, instead of waiting for our code to crash to do debugging, we can do set what's called breakpoints. So here are your line numbers. And then if you see, as I approach the line numbers, this red dot starts appearing. You want to press the button. It's very tempting, and you do want to press it. When you press the red button, you've created a breakpoint at that line number. And what happens when you create a breakpoint is that it tells the Python debugger that I want to stop my code when I hit a breakpoint. It hasn't crashed. We're just stopping our code just to see what's going on. So if I rerun the debugger, you'll see that the code will stop at the line we set the breakpoint. So the code hasn't crashed. It's just like, you've asked me to stop here, so we're going to stop here. So when you stop a code at a breakpoint, we haven't executed that line yet. We've executed everything up till that line. So you can inspect your variables. So here's here's dim2. You can inspect new image. New image hasn't been defined. So we maybe want to define. So if you want to execute this line of code, you want to use the step over function. The step over command lets you execute a line of code and move to the next line in this function. So we can do step over. Now new image has been defined. New image looks like it's an array, and let's move on for now. So you see we're now at the for I in range dim line. So we skipped all the comments and free spaces. We're going to the next line of code execution, and you can be like, okay, let's step over that line, step over that line. They're like, oh, there's a function. I want to understand what's going on in this function maybe. So let's if you click step over, then it's just gonna go to the next line of code. You're not gonna go into the function. If you want to go into a function, you use the step into command. So step into command while you step into this function. It's important to click this before you pass that line of code, and otherwise you lose your chance to step into it. So you step into that function, and see now we've gone into that function of that line of code. So you can actually look at your call stack, and you can see that normally we're just running things in our module debug.py, but now we've actually gone into a function called generate RGB pixel. So you can see we were here, but we've now stepped into that function. And so now we can look at every line of this function and see what it does. Looks like the first line, we're doing some like numpy.random number generator. They're like, oh, let's skip that line. They're like, oh, this function looks way too complicated, but we can see that it's returning red, green, and blue. That's like all we want to know. It's like it returns 3 different things. And you're like, maybe this function is like 100 lines long, and I don't want to click step over 100 times to get out of this function. So you can click the step out of function, and this will execute the rest of the lines of this function and return you back to where this function was after it just executed. So we'll return you back out here. We still haven't executed this line. We just executed this portion of this line of this function. Okay, so then you're like, okay, I know what this line does, and we get to here, and this is where things are going to crash, I bet, right? So we can double check this is where things are going to crash. We go back into our debug console, and we can, before the code crashes, we can just execute this line in the debug console. This is a safe zone down here. If things crash down here, it doesn't crash the rest of your code. It just crashes down here. So you can be like, and like, yeah, you get the same error. Classic. And then maybe you look at this closely, or you realize that you're trying to, I think as I hinted before, because I already knew the answer, we are trying to set this new image jx comma I is 0.0, and then pixel RGB is 3 values. You're trying to set 1 value to 3 values. That probably doesn't make sense. And that's probably because this new image doesn't have a third dimension. So let's give it a third dimension. We need a third dimension of 3, because we want to make a 2D image x comma y, but for each pixel we need to specify both its RG and B value. So it needs to be a 3-dimensional image to specify the RGB value for each pixel of our 2D image. All right, so like, great, that fixed the bug. Let's try running the whole thing. So after we think that should fix the bug, maybe let's confirm that should fix the bug. So let's set our breakpoint down here. We're going to click start debugging. So we can try to execute this line of code and see if it crashes. Like, aha, it didn't crash. And you can keep executing. You're like, look at this. This is amazing. Things aren't crashing. This is fantastic. Okay. So let's just keep running it. So I can remove this breakpoint. I can click to remove. That breakpoint is now gone. So we're no longer stopping the code here. And we can click the continue button. This will continue until we hit the next breakpoint or our code crashes. Like, let's going. You're like, crap, crashed again. I thought it's the same line of code. We just fixed that line of code. What's going on? So let's see what's going on. So we got another error. Index 35 is out of bounds with axis 1. For axis 1 of size 35. So if you hover this, you're like, okay, this is 0. This is 35. Okay, so something's weird here. So let's try calling this. So let's copy this. And you're just like, that doesn't work. You're like, why doesn't that work? You're like, maybe let's check out the shape of that image. So it's a shape of 105, 35, 3, and we're trying to index it with j, I, which is 0, 35. And you're like, oh, 35, 35. That probably doesn't work because we've, we're trying to do 35 both times. So you realize we probably swapped the indices of j and I probably. So if you look here, I is going from 0 to, just cover 105. And then j is going from 0 to 35. So 105 should be indexing the first dimension and 35 should be indexing the second dimension. So this means that I and j should be swapped. Like, okay, cool. Maybe that will fix things. So let's stop our debugger. So we fix that bug. Every time you make edits to the code, that doesn't happen. That doesn't change what's happening in the current debug session. If you make edits to the code, you need to stop the debugging session and rerun it to reflect those edits. So let's check that the line doesn't crash anymore. We can, and since we're overly careful, we want to make sure that that line doesn't crash before we execute it. So we want to stop here to make sure, but we don't want to go through this like 35 times until it crashes. Like that's way too much of a pain. So we can set what's called conditional breakpoints. So if you right click on that breakpoint, you can go to edit breakpoint. You can say, I want this to stop when I equals to 35. And now this breakpoint will only happen when that condition is true. So we go back and hit play, the green button. It's going to keep executing until I equals 35. So now we hover over I is 35, and j is 0. So let's check to make sure this works. I like to do this just in case things crash. That's why this is the kind of habit I came up with. Oh, looks like it doesn't crash. That's great. Let's just keep running it. So let's remove this breakpoint, remove breakpoint, and keep running. Whoa, nothing happened. Did we make an image? We lost the image. What happened to the image? So you saw that something flashed on the screen, right? There it is. Okay. It's the curse of the demo. So we've created our 2D pixel art successfully after debugging our bugs, but hopefully that showed you some of the examples of the VS Code debugger that we're able to, do post-mortem debugging, so we can stop our code when it crashes and like see what's going on at the exact line things crash. We can manually step through our code line by line, going into different functions as we want. And this is a really powerful way, especially if you have many lines of code, when you're dealing with code bases with hundreds, with thousands of lines of code. Printing everything, it becomes impossible at some point. You need to be able to precisely go through various parts of the code and inspect things there. So that's the whole point of the debugger. It is a little bit of a process to learn. This is one of those things where it's like, okay, debugging with print statements, like how I've done it in the past, or however I've debugged in the past, works quite well. I'm very good at that. This is a whole new thing. At first, it's going to be kind of slow and it can be a little painful to figure out how to do it. But at least for me, over time, this is so much faster now for me to debug than it is with print statements. Question? Yeah. So I guess one thing I think we covered in the video on day 0, but it probably slipped through everyone, is you want to set your Python environment to your Code Astro environment, and you do that in the bottom right corner. So here, if you look in the bottom right corner, if you open up a Python file in VS Code, it will tell you what version of Python is using for VS Codeness. And if you click down here, you can select which of your Python environments you want to use, and you can select on Code Astro, and then everything in VS Code, unless you manually change your environment in the terminal, will use the Code Astro version. So so you will have to do that. For the next, how long did I say this activity is going to take? Give me one sec. Okay, so for the next, let's say 30 minutes. Yes, 30. No, wait, no, I have to tell you what you're doing first. Okay. Good notes to pass myself. Okay, so we're gonna practice trying to use setting up the debugger and using it for activities. So you're gonna actually, your task was with investigating a bug. So we've created a bug in Orbitize for you to test. If you click on this link, and here's the bug report. So this is kind of like a basic but standard template for a bug report. So I was trying to run, in this case, I was using some random inputs for this orbitize function. You don't really have to care what this function does. It's called calc_orbit, and is returning all nans, which is not desirable. Do you know what's causing this? So this is how, and oftentimes in a bug report, it's most helpful if you provide a code snippet that reproduces the bug. And the code snippet should be as short as possible. So hopefully the shorter it is, the easier it is for someone to kind of grab it and run it. So here you see use import. If I do these two imports and then call this calc_orbit function with a series of random numbers that I apparently decided to call it with, if I print out RA, dec, and RV, these three variables, the outputs, let's say nan, 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 Batman. So we want to understand why it's doing that. So that's your task, is to go into Orbitize and figure out a code base that you've never seen. You don't even know what it does probably, and figure out what line of code and what input variable caused which of these 9 input variables caused our code to produce nans. So this is like it's a very good field test, because oftentimes, you know, we're given codes written by other people, and sometimes the codes don't work, and you have to figure out what's going on with them. And the debugger for me is a very good way for me to basically fix any issues when I'm running in other people's codes, especially because I don't really understand what other people's codes are doing, especially if they're very long. Okay, so this is the reproduction of the code. So your activity is to actually try to figure out. You've actually installed, if you follow the day 0 install instructions, you've already installed the development version of Orbitize probably, so you can probably skip this step. But if you run into any issues, one of the things such as I can't access my Orbitize files in the debugger. If you run into that issue, you probably need to install the development version of Orbitize. But you probably did that, so you can skip that step. The next step is to set up your VS Code debugger on your machine. Let's do this in groups, so we're not trying to everyone set up everyone's VS Code debuggers at all times. This is usually a part where we run into some issues. So let's get it set up on one person's machine first, get this working, and then we can try to get the debugger set up on other people's machines as well. And probably the second time, the first person is actually going to be the guinea pig. After you see it on the first person and you see all the mistakes, you know, the issues you run into, then you know for the second time what not to do when setting up the debugger. So you can follow these instructions for setting up the debugger. It's the same instructions that I showed in the demo when I was demoing the VS Code debugger. So I'm not gonna do it again because it's the exact same instructions. So your goal is just to follow the instructions above to get your debugger set up, reproduce the error in the day 2 part of our Code Astro. We've actually supplied broken orbitize.py. This is the exact same code that lets you reproduce the error. And if you know, and this code should crash because these 3 lines all will assert to false and basically cause your code to crash. So you can use this code to reproduce the error. Otherwise, you can copy the code from that issue and reproduce it yourself. At the end, we're going to put a post on Piazza, and you have to identify 2 things. You know, at what line of Orbitize do nans first start appearing in the code? So at first, nans don't first start appearing. So what line of orbitize does nans start appearing, and which of the 9 lines of input are causing the function to return nans and report on any modifications that you made to fix that. That's a bonus activity on how to fix that. The main thing is just figure out what line of orbitize starts appearing nans and which of the 9 inputs is causing the function to return nans. Only one, actually, yeah, I'll give you a hint. Only one of them is. So you got to figure out which of the 9. Great. So hopefully you got a taste of the debugger. The debugger is one of the top things I go to anytime I'm trying to debug, figure out some issues. But there are some other kind of debugging tips I wanted to share. Like I said, there's no one recipe for debugging, but there are some general tips that you might find useful. So one kind of philosophy thing is you have no idea what's broken, try to at least first establish what's working. So like rule out things that you know are doing the right thing, so that you have less, like, there's a general philosophy like you're like something out of everything here is broken. Let me just try to figure out which lines of code are indeed working and then work my way up and narrowing things down. A good process of elimination, I do this in debugging all the time, is this idea of what's called binary search. So if you have 100 lines of code and somewhere in it is produced, like something is going wrong in that 100 lines, you can first split it up being like, is it the first 50 or the second 50? You can like literally comment out the second 50 or the first 50 and see like, like comment out the second 50. Does the first 50 run and produce the same answer? If it is, then it's somewhere in the second 50, and then look in the second 50. Then split that into half and look at the first third quarter, look at the one quarter and look at the other quarter, comment out one of the quarters and see, and just work your way down. This way you're kind of like, this is like this binary search is often an algorithm used in programming to find something, and this is just like debugging is something to find something, and this is probably one of the more efficient ways to find things rather than kind of look line by line, look chunk by divide things into halves, look at which half it is, and then split that into halves, and keep finding it there, and hopefully that should be quicker than trying to search line by line, especially if you have hundreds of lines of code to try to figure out. Googling error messages is very useful. You get very good at figuring out which parts of the error message to copy and to get you the right Stack Overflow answer. But one thing is, think about what commands they are suggesting to you to type, and don't blindly type them. Think about, okay, this is the command they want me to type. What is this command actually doing? Because people can maybe sometimes give you bad commands or maybe sinister commands that you should be typing. Anything, especially with the word sudo in there, you should be thinking, do I really need to be doing this? Like, what is this command actually going to do to my computer? Yeah, like I said, using interactive debuggers like the one in VS Code allows you to, it's really helpful, especially if you have lots of lines of code to sift through. So I highly recommend learning that. That's one of the ways that really cuts down on my debugging time. Especially now I work on a lot of big packages. I have thousands of lines of code, and there's people, a lot of the code isn't code that I wrote myself. So, or it's code that I wrote 5 years ago. So it's basically like someone else wrote that code. So in both cases, very useful to have the debugger. Another thing which we'll talk about later this week is writing tests for your functions as you're writing the functions themselves. This is called test-driven development. You can you write a function while you write a test for the function while you're writing the function, and this will help clarify exactly what that function should do, and you can use that test in the future so that if things break, you're like, I know this test was working, but now it's broken. What has changed between now and then? Like when the test is working and when the test now breaks, you figure out, which part of that delta is causing things to break. It's not every line of code, it's only the things that change in between that are causing things to break. And then the last thing is, you kind of have to keep at it. As you do more and more debugging, you kind of develop more and more of an intuition. You kind of find all the tips, like little small tricks that kind of get you, there's a bunch of small things and things that happen over and over again. It's hard to write them all out because there's hundreds of them, but eventually you start mentally having that list, and you'll start being able to recognize when this kind of error occurs is probably due to this thing. Like anytime people are like, I can't import orbitize, it's like you probably have the wrong environment in your VS Code setting and goes to your bottom right corner. And it's because we've taught this thing 5 years, and every year we should really put that into the instruction somewhere one of these years. Okay, so that's everything for debugging. That's actually everything